Hello guys, welcome to my channel. So as you have already seen the title, here in this video we are going to talk about Java developer roadmap. So this is going to be a basic backend developer roadmap, and this is specifically for 2025. So if you are still wondering that if you should learn Java in 2025 or not, this video is for you. And if you want to learn Java in this year, then what you need to learn to become a Java developer or a Java backend developer. So this is what we are going to talk in this video. But before we do that, if you are new to my channel, if you haven't yet subscribed to my channel yet, please do. It's a simple thing that you just hit the subscribe button. That's it, nothing else. There is no money, there is no hardship involved. You just have to hit that subscribe button. That's it. Now let's kickstart this video. So hello everyone, welcome to my channel. If you want to become a Java developer in 2025, this is your ultimate roadmap. So in this video we are going to cover everything you need to learn from Java basics to advanced frameworks, databases, DevSecOps and best practices. Make sure to watch this video till the end because I'm going to share all sort of tips to help you out stand in the job market. So let us begin. So in this video we are going to talk about roughly these things. We have Java basics, we have core Java and advanced concept, we have Java frameworks, then we have databases and tools, then DevSecOps or DevOps and cloud, and then we have system design and DSA. So these are what we are going to discuss in this video. So first thing first, we have to master the fundamentals of Java. So you need to be solid with variables and data types, operators, loops and conditional statements. You need to be familiar with object-oriented programming like your classes, objects, inheritance, polymorphism and exceptional handling. So these are some of the fundamentals that you need to be aware of. If you are not aware of it, then you are not going to learn a lot of things when you move ahead in Java. So if you want to work on advanced concept or if you want to become a fully fledged backend developer, then you need to learn basic fundamentals of any programming language, no matter if it is Java or Python. So here these are some of the basics that you need to learn. Like you have data types, you have object oriented programming, you have control statements and you have exception handling. There are a lot of other topics, but these four are major thing. Now if you're wondering where you can learn these, then these are some of the websites that I actually use in case if I want to learn anything new. If let's say if a new Java version is coming soon, then if you want to know about it so that I'm up to date in the job market or in my Java world, then I need to open these websites and learn about these new things. But if you want to learn particularly basics of Java, you can go through these websites because they will help you out in every way. Now Java Docs is at the top because this is the official documentation along with your Oracle tutorials. So if you want to get the official documentation, go there. But if you want to learn in basic terminology, then go to Geeks for Geeks and Code Academy. Alright, then we have core Java and advanced concept. So once you understand the basics, it's time for core Java and advanced topics. So we have topics like collection framework, which includes list, set, maps. Then we have multi-threading and concurrency. Then we have streams API, functional programming, which came in Java 8. Again, the new functionality coming through a particular Java version. Then you have JVM internals and garbage collection, along with you have design patterns in Java. So if you want to learn about these concepts doing some kind of project, then do that, because if you write small project using these concepts, you will reinforce learning. So it will be very beneficial for you if you write down code or create some basic project to learn these concepts. So just for example, if you want to learn collections, then you can use any dictionary based or any hash map based project, which is going to be beneficial for you if you want to learn collections. Now talking about streams API and functional programming, if you want to get the data from the database or insert the data to the database, things like that, where you have a large data set, or if you want to iterate over a large data set, in that case use streams. So that is going to be one small project that you can do to learn basically about streams. Then you have multi-threading and concurrency. So these are some of the backbone topics of Java. So multi-threading and concurrency is why people are using Java still in 2025. So multi-threading and concurrency is a very advanced topic, to be frank, but if you want to learn about it, try to create a bank-based system, or let's say a security based system. So let's say a payment gateway. So there you are going to use multi-threading and concurrency. So if you are a beginner, if you're just trying to work on Java, then you can use even and odd numbers using 2 threads. This is a very basic example through which you get the fundamentals of multi-threading. You can use thread synchronization with bank account. You can use producer consumer problem using blocking queue. That is the official answer to it. And then you can also try to make multi-threaded file reader. So that is what you can do. If you are intermediate, then you can use web scraper using multi-threading. For this you need to use executor service. Then you can also use parallel merge sort. So if you don't know about merge sort, it is again an algorithm for sorting. So you can use merge sort using fork join pool, which is again a framework in Java. So yeah, these are some of the projects that you can do in multi-threading and concurrency. Now we have JVM internals and memory management. So you should not try any project on these, because these are some of the core concept of how Java basically work. So if you want to learn about JVM internals and your memory management, try to read about Stack Overflow error and how you can basically debug memory leaks. And if you still want to create project on JVM internals and memory management, so you can try to create a JVM memory usage controller. So this will use your runtime class to get heap memory usage on runtime. So this will print total memory, free memory, and used memory. You can also use object creation and garbage collection demo. So this is a very basic example, but you can try to mimic that and see if you get the hang of how JVM works internally. Now if you want to practice about core Java and advanced Java, then you can also use LeetCode, CodeChef, HackerRank, and HackerEarth. So these are very competitive websites where you get a ranking, where you get interview questions based on DSA basically. But when you talk about DSA, that is all about collections, map, list, set, right? So if you let's say want to try your string concept, if you want to try your map concept, then what you can do is you can try those selective questions on these websites and try to get the hang of how these collections work in Java. You don't have to be competitive about it, just try your basics and get comfortable with it. That's it. Do not be competitive here, right? Now Spring Framework and backend development. So when we move to SpringBoot, this is basically the most used Java framework in real world applications right now. So some of the topics that you should be familiar with are your Spring Core, Spring Boot, Spring MVC. So before we had Spring Boot, we basically had Spring Framework. So you should know about Spring Framework in brief, and then you can work on advanced or basic concept of your Spring Boot. You should be familiar with how to build REST APIs, how to use Spring Security, authentication, and authorization. You should know about JPA. That includes your Hibernate, which is basically used for database integration. Then you should be familiar with microservices architecture. Now these are some of the topics, but the tools also you need to be familiar about are your Postman, Swagger, and Lombok. So Lombok is basically a good library when you don't want to generate setters, getters, or maybe constructor. Then you can use Lombok. So this is basically an annotation based framework where you can just provide the annotation and the stuff will be generated for you. You don't have to generate anything on your own. Then you have Swagger, which is for your API documentation. So if you're working on REST APIs or maybe microservices, then you want to document them, because if you are a developer, if you're working under a team or with a team, then you want to document everything whatever you are doing, so that another developer or other team basically can pick that document, read about it, and get the hang of what you were trying to build. Then you have Postman, which is basically a testing tool for your services. So if you are developing something and if you want to test something, then use Postman. But other than Postman, you can also use Google Chrome. That is also a good thing, but Postman is giving you a lot of other features over Google Chrome. Now one tip that I want to give here is that do not read about Spring Boot theoretically. This is not going to help you in any case. Just create a lot of web applications like your to-do application, your event management, or you can also create a web calculator, which is basically a Chrome or browser based calculator. So try to build something, otherwise even if you try to get the hang of it theoretically, when you actually want to use those concepts in an application, things will get difficult if you are not familiar with it 100%. So if you learn about it, then also create 1 or 2 projects, right? Now moving on, databases and storage. So every backend developer must understand databases. The reason is that when you actually create code, so every code has a storage. So whenever you basically do a computation from A to B, or let's say if you have a file, if you're just reading that file, then you have to store that data or that computation, whatever you have calculated between services or from the browser, whatever you get from the client. So that computation you want to store somewhere. But if you are not familiar with databases, then you are actually dependent on the frameworks or basically your DBA, which is your database administrator or developer. So if you are familiar with databases, then things get very easy for you to create tables, to create databases, to manipulate tables, or basically create stored procedure. So some of the databases that are being used right now are your SQL databases, which are very popular and legacy based. So you have MySQL, Microsoft SQL. So these are some of your legacy databases, and now you have PostgreSQL as well. Also you can use NoSQL databases, which are basically your MongoDB and Redis. And if you don't want to write any query, then use ORM tools, which are your Hibernate and JPA. Now you should know about database indexing and optimization. Why? Let's say if you're working on a project which is already built up, so let's say if it has been there for, let's say, 10 years, then now the database is not that efficient if you're working in 2025. So what you need to do is you need to work on database optimization, or maybe query optimization, or put some indexes in the table if they are not there, or remove the existing indexes and create those indexes on some new or other efficient columns. So things like that you have to decide whenever you're working on a real-time application or real-world application. So you should be familiar about optimization and indexing, which also includes caching. So caching is also a good concept which you should know about if you are using a real-world application. Now DevOps and cloud. So the industry is moving towards cloud-based applications these days, as you know about AWS, but there are a lot of other things that are also being used along with your cloud. So what to learn is you should know about Git and GitHub. So these are basically your version control, which comes under your DevOps. So if you are working on a repository, then it is going to be a good thing, because you can commit the code and other developers can pick that code and they can commit the code, and similarly you can fetch the code. So this creates an ecosystem where you can all work together, correlate together, and be in sync, right? So Git and GitHub are very popular these days. Then you have Docker, Kubernetes. So these are for your containerization and imaging. So let's say if you have an application which requires a particular set of applications to be installed along with that application, and if let's say you have 10 clients, which means that you have to install your application at 10 places. So if you manually install all those software to run your application, then maybe something breaks, maybe something doesn't work, then things get very tedious in a tight timeline. So what you should do is you should create an image and containerize it, so that when you actually install, you install it as a bundle rather than individually. Then you have your CI/CD pipelines, which basically is your deployment and integration pipelines. So these are your Jenkins and GitHub Actions. So GitHub Actions are basically some of your static pages that you can have whenever you have something that you want to showcase whenever someone is visiting your repository or pipeline. Jenkins is very famous and very futuristic in short terms. So Jenkins provide you a lot of features where you can create your pipelines, do some kind of automation there, so that whenever you actually create a pipeline, commit a code, build it, and then try to deploy it someplace else, then between these steps you can try a lot of things, and that is completely customizable. So Jenkins is a very good tool. Then the main topic is your cloud computing. So cloud based platform are really famous these days. If you are a backend developer, if you want to become a backend developer, if you know about AWS or GCP or Azure, then you are going to get preferred over those developers which don't have any kind of experience on these three. So pro tip here is that deploy your sample application that you have created as of now. It doesn't matter if it is a fully fledged application or a very basic calculator application. You should deploy it on AWS or any other cloud-based platform to understand real-world cloud implementation. Now, just a pro tip. Another pro tip, I have given already a pro tip. Another tip is that AWS and GCP are free for certain usage. So if you are working under these conditions where these platforms are free, then you can use it. Don't worry about paying or billing anything. Just work on it, get the hang of how these cloud platforms work. Now, the Mang and Fang company's favorite topic, system design and data structure. So these are very famous right now in every YouTuber video. So you can see a lot of videos where they are just talking about system design and DSA. So this is not a must. That is why I'm keeping this at step 6 and not step 1. So if you know about Java, if you know about cloud platform, and if you are well versed with databases, then this is secondary, right? I have taken a lot of interviews where I haven't asked any system design and data structure question. It doesn't matter to me if you have a basic Java knowledge, and if you are let's say fresher or under 2 years experience, that doesn't matter. You can still get the hang of it and you can still learn. So these kind of questions doesn't matter for me, but a lot of organization, a lot of product based organization talk about these. So you should have some basic knowledge, not advanced, some basic knowledge of these topics. So data structure and algorithm basically are to crack FANG level interviews, not joking, FANG level interviews. So if you are talking about basic product based organization like your Ericsson, so if you don't know about Ericsson is a product based organization. So if you go there, they won't or they may not ask about system design and data structure. So there are a lot of product based organizations where we don't talk about system design and data structure, but Mang and Fang level interviews talk about these. So data structure are your arrays, linked list, trees, graphs. These are some of the favorite topics. And in algorithms, sorting, searching, and dynamic programming. Now you have, if you crack these interviews, then you will be interviewed on system design, where you have low level and high level system design. Then you have to talk about scalability, load balancing, and caching. Right. So here the pro tip that we have already talked about: use LeetCode, CodeChef, hackathons, and they are very competitive. So you can try to be as competitive as you want. But there is a pro tip again here, that first get familiar about Java or Python, whatever you know about. Then get familiar with these languages first. Learn basic and some advanced topic of these languages. Then come to this part. Not the other way, right? Now I'm done with all the things that I wanted to highlight here, but still some additional tools and best practices. So every developer should know about these. If you are actually working in an organization, let's say TCS, Infosys, then they know about it. So I don't have to highlight this, but remember, when you actually get the interview and when you actually crack that interview, these are your things that you have to work on. This is a must. So you have to open a YouTube video after you get interviewed. So it's good if you know about it before the interview. So for testing, we use a lot of JUnit test cases and Mockito for mocking. We have logging frameworks like Log4j, SLF4j. For API documentation, we have talked about Swagger. Then we have monitoring tools like Prometheus and Grafana. Then we have performance optimization and code quality, for which you can use profiling and caching. Now, there is one more tool, which is your SonarQube, and SonarQube I use in my current organization, and I have seen it in other organizations as well. So SonarQube, a lead developer in your team will use to review the juniors or seniors code, so that he knows that if if there is a cyclomatic complexity, if you are working on a particular convention or not, if you are following all the good practices that every Java developer do, so things like that. So that is why I'm saying, if you know about all sort of things, still you need to get the hang of conventions, like how to create a method name, how to follow the method structure, how many if-else conditions or nested if-else conditions you can keep in a method. So these are a lot of things that you should be familiar about, but again, these are secondary, not primary. So if you are working on a certain roadmap, these comes at the last. Alright, so let's summarize what we have talked about today. So we have talked about in a nutshell that learn Java basics, master core and advanced topic of Java, learn about Spring Boot and REST APIs, databases and storage are a must. You should know about DevOps and cloud-based platform. Then you can be familiar with system design and DSA, which is not a must, but if you know about it, which is good. Then you have some essential tools and best practices which you should be familiar with. Now this is it. This is what I wanted to highlight in this video. If you found this roadmap helpful, don't forget to like, share and subscribe. Let me know in the comment which topic you want a detailed tutorial on next. Follow me for more content. Thanks for watching and see you in the next video.